In this lecture, we're going to cover electric charge. First, let's talk about charging by rubbing. When you take two non-metallic objects, such as a plastic ruler and animal fur, and rub them together, you get an interesting effect. Before they are rubbed, the plastic ruler is held over bits of paper and nothing happens. After the rubbing, the plastic ruler is held over the bits of paper and they are accelerated towards the ruler. Here you can see a picture of it. Before we rub the ruler and the fur, nothing happens. We then rub the ruler with the fur, and look what happens after rubbing. The pieces of paper are accelerated upward towards the ruler. Since the paper bits were accelerated upwards against the force of gravity, what interaction was occurring between the ruler and the paper? That's right, a net force. It has been known since ancient times that when certain materials are rubbed together, they develop an attraction for each other. This can be seen today when you take clothes out of a dryer. In ancient Greece, people noticed that when thread was spun over a spindle of amber, the thread was attracted to the spindle. The Greek word for amber was electron, hence this force was called electric. Further experimentation showed that dissimilar materials would attract each other after rubbing, while similar materials would repel each other. These effects would not happen without the contact, and later, given enough time, the forces of attraction and repulsion would stop. This led to the thought that something was being exchanged between the materials, that this something was later called charge. Because objects would be repelled or attracted, it was postulated that this charge came in two types. In the 18th century, Benjamin Franklin noticed when a rubber rod is rubbed by animal fur, the rod acquires a negative charge and the animal fur acquires a positive charge. When a glass rod is rubbed by silk, the rod acquires a positive charge and the silk obtains a negative charge. Thus, two rubber rods, after being charged, would repel each other, while a rubber rod would be attracted to a glass rod. No new charge is created. Instead, it is just separated. The positive charge acquired by one object is exactly equal in magnitude and opposite in sign to the charge lost by the other object. What is another way of saying this? Another way of saying this is that electric charge is a conserved quantity. The total amount of electric charge in a closed system remains constant. It is neither created or destroyed. Just like energy, linear momentum, and angular momentum are conserved quantities. In the next part, we're going to be doing problems. A neutral plastic rod is rubbed by a piece of animal fur. Describe the charge on each item. A, both items will be neutral. B, the fur and the rod will both have a negative net charge. C, the rod will have a negative net charge and the fur will have a positive net charge. D, the rod will have a positive net charge and the fur will have a negative net charge. If you have to, pause the video now and select your answer. Let's check and see if you were correct. The correct answer is C. The rod will have a negative net charge and the fur will have a positive net charge. A positively charged object is moved towards a negatively charged object. What is the motion of the objects when they come close to each other? Is it A, neither object has any effect on the other, B, the objects move away from each other, or C, the objects move towards each other? Go ahead and pause the video now if you need to and answer the question. Okay, so let's see if you selected the correct answer. The correct answer is C. The objects move towards each other. A neutral glass rod is rubbed by a piece of silk with no net charge. The rod gains a positive net charge and the silk gains a negative net charge. What is the sum of the charges on the silk and the rod? Is it A, 0, B, twice the charge on the rod, C, twice the charge on the silk, D, 1/2 of the charge on the rod? Pause and select your answer now. Okay, so let's see if you have the correct answer. You should have chosen A. Remember, charge is conserved, so the net charge will have to be 0. Two pith spheres covered with conducting paint are hanging from two insulating threads. When the spheres are brought close to each other, they attract each other. What type of charge is on the spheres? After they touch, will they separate or cling together? Discuss all of these possibilities. So go ahead and pause your video now and write down what you think happens when they touch, and then tell me what type of charge is on the spheres. Okay, so let's see if you have the correct answer. Since the spheres attract each other, they have opposite charges. If the spheres have equal amounts of charge, they will neutralize after touching and hang from the threads vertically. If one sphere has a larger amount of charge, they will share the charge after touching, which means the same charge will be on each pith ball, and then they will repel each other. In the next video, we'll talk about atomic structure and the source of charge.